Okay, now see, as I told, the feed, I told that the in turning center, the feed can be defined by mm per minute or per revolution. Okay, so the how the computer will understand whether we are going for per minute or per revolution, that can be defined by writing either G98 or G99. Okay, these are some of the G codes. Now coming to some of the M codes that we will use. First is M00. This is a temporary program stop, and M01 is some optional stop. M02 is program end. M03 is clockwise spindle rotation. Okay. M04 is counterclockwise spindle rotation, and M05 is spindle stop. Okay, that means prior to any machining action, we must start the spindle whether clockwise or counterclockwise by writing M03. Okay, and uh, also we have to specify what is the spindle speed. We'll discuss that. And once our program is over or the machining part is over, we must stop the spindle by writing M05. Okay, and this coolant also. So prior to any machining action, we must start this coolant pump on by writing M08, and once it is over, we have to write M09 so that the coolant pump will be off. Now chalk clamp and chalk on clamp. I told here there is no manually we are fixing the job. We can hold the job and we can write this code means it will automatically clamp the job, and once the job is done we may write M11 so that this will be unclamp and unclamp the job. Okay, and coming to once our program is over means we can write M30 so that the program end, and M41 is for spindle speed low and M42 is spindle speed high. That means whenever we are operating a spindle speed more less than 1000 rpm, we can define it by M41 so that machine will understand that spindle speed low, and M42 means when we are operating at a higher spindle speed more than 1000 rpm. Okay. Someone asked why the M16 is missing. Okay, see, there may be a number of G codes and M codes. Here we are discussing some of the general G codes, M codes. Okay, and it so there may be some M16 value which is not relevant to us, or it may not be there also. Okay, so just we are discussing some of the few G codes and M codes which are
Sir,
used for the practical application. Okay,
sir, we have to remember all these codes.
okay. Uh, not means whatever I have highlighted means those are we will use in the program. So mostly that will be helpful. Okay, there may be number of G codes, M codes. So whenever you will go for the means you will operate on that machine means you will have a manual. Even if you forget means you can check and just check these things. Okay, otherwise you have to remember some of the few things like M0, M01, M02, basically this clockwise spindle rotation or counterclockwise spindle rotation, coolant pump on off, and also in your exam which will be conducted after this semester they may ask you some sort of this course means what do you mean by G01, multiple type of questions. What do you mean by G00, G01 or M03? Those type of questions are also can be asked. So prior to that you may just go through these slides and whatever is we are supplying, that is I think enough for you. Okay, now coming to some programming modes. There may be some incremental systems or absolute system. Okay, I think there is some mismatch in the slide. See, uh, so now, uh, prior to machining, we must specify some coordinates system. Okay, so there is a in absolute programming, all measurements are made from the part origin established by the programmer and set up by the operator. Suppose let's say we have to we have to move the tool from point A to B, then C, then like this. Okay, so in absolute programming, uh, all the measurements are done from this point. Okay, and in incremental system, we have to, wherever the tool is present, it will consider it as the 0 0, and it keep on changing. Okay, so in incremental programming, the tool movement is measured from the last tool position. I think it is confusing, but it will be clear in the next slide. Just see, suppose we are here. Okay, and we want the tool to move A to B, C, then D, like this up to again to the A. Okay, so if we want to write the program in absolute system, that means 0 0 will be means this A, the coordinate of A will be 0 0. What we can write, we have to specify to the machine by writing that G90. That means it will understand that we are following this absolute system. So G90 is for absolute system, and then G01 for linear motion interpolation, and what is the coordinate of the next point like B. So it is at a distance of 50. So it will be x50, and here also we must specify some feed, that F100. Okay. Now the same program, if you would like to write in incremental system, it will be also, instead of G90, we have to specify G91, then G01 for linear interpolation, then X50 from A to B. This is 50 mm. So you have to write X50 and F100. For first line, it will be same. But now coming to the second line, means when the tool moves
So
from
what is
B
the
to C,
difference between absolute system and incremental system?
So,
just wait.
so can you again explain?
Okay, just wait. If you will miss the thing while explaining this, again I will tell. Now see, we have to move the point from B to C. Now, if it is a absolute system, we already know that this is 0 0. So now we have to go from B to C. So as per, if this is 0 0, what will be the coordinate of the C? It will be, x will be 70. So we can write G01, x70 and F100. But if it is an incremental system, my tool is already here. Now it remembers B as its origin. So from B to C, it will take, what is the value? B to C means it is uh,
30.
okay, it is 30. So it will be, I think, x30. No, no, sorry. No, no, see. B means this is 50, this is 70. So from B to C means it is
It is
20 mm.
20.
Okay. So now in incremental system, it considers B as its origin, means it is kept changing. So from B to C, what is the movement? It is 20. So we have to write only x20. Okay. So yes, incremental system is like shifting of the origin. Okay. So see, we may write x70 or x20. It means the tool path will be same, but accordingly we must specify by either writing G90 or G91. Okay, is it clear?
Sir,
Yes,
sir, sir,
yes.
from B to C, it is moving a little bit diagonally. So, how can we specify that direction?
Okay, no, this is a straight line actually. Just imagine that this is a straight line. Okay,
Okay, okay, okay.
okay. Now, um, C2D means C2D means this dimension is 130, so we can write 130. But when it is, we are writing in incremental system, this, if we'll take it as 0, 0, the D will be at a distance of 60 mm. So it will be x60. Okay. Now from D to E, it will be suppose D to E. What is the location of E with respect to A? It will be 100. It will be 100 in absolute system. But in incremental system, that means the tool has to move like this. That means it will be 30 mm in other direction. So it will be x 30 minus 30. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
So
Yes, sir.
that
Yes,
means
sir.
Yes, sir.
yes. That means we can write the program in both the system, absolute system or incremental system, but we must define it by writing these G codes and accordingly in the program. Okay.
So in D2E, we are not using Y coordinates.
What?
So in D2E motion, we are not using Y coordinates.
No, this is just for an example. Okay. Just for the clearing this any doubt for the absolute and incremental system. We will again, while writing the code for our actual program, we again that will be both the things will come X and Y. Okay.
Sir, but D2E and
Sir,
B2C Y coordinate is also changing.
Yes, it is
Wha-
changing, but just for the simplification, we just mention it only x value, because in the program diagram also it is only giving the x value. It is not giving any y value. Okay, just for the uh, for understanding purpose, I just wrote like this.
Sir, but
sir,
in
what
I
is the use of the F100 command?
Okay, see, F100 means this is the feed. F capital F is for feed, and 100 means this is the numerical value. Okay, so it may be mm per minute or mm per revolution. That is also based upon like this G code.
sir,
Yes.
Okay.
sir
If we
in
are writing,
B2C, sir
if we
in
are writing,
B2C, in B2C, why have you cut the G01 and F100?
I will tell that. See, if it is a G98, it is mm per minute, or if it is G99, it is mm per revolution.
Okay, sir.
See, okay. Why I have cut this G01 F100? See, here we are only dealing with the linear motion or linear interpolation. If I will keep on writing this G01, it will be an unnecessary action. Okay, and also I am doing the machining with the same feed. So instead of writing this G01 F100, I may skip this process and machine will understand the same meaning. Okay, so I have intentionally written it and cut it. That means even if I write or do not write, machine will understand the same. Okay.
Okay, sir. Okay.
But see, let's
That is
see.
we have to write only at one time.
Yes. But if
Yes.
it is a circular motion, circular interpolation, then we must specify a G02 or G03.
Yes,
Okay.
sir. Yes.
And again, if we are changing from circular interpolation to linear interpolation, again we must specify a G01. Okay.
Yes, sir. Yes. Yes.
So, uh, and someone asked why we are using this semicolon. Okay. So we are using this semicolon to specify that. Okay, just let me complete it. So there is a common mistake that we observe. Suppose we are moving from 0 0 to 10 comma 0, then we are coming to this point. That means we want this tool to move in path like this. Okay. For that, what will be the program? It will be like G90, G01, extend, then comma, or then Z7, so that it will take this path. Suppose by mistake we are skipping this. This is called the end of block. If we keep on writing this, that means the one line is over. Okay, but suppose by mistake we just didn't we missed this. Okay, now what will be my next? Will the tool move in the same path? No, it will consider this two line and a single line. So instead moving taking this path, it will take a diagonal path to directly to that point. Okay. So if we do this type of mistake, then it will entirely damage the part. Okay. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now here you see I have
Sir,
skipped
can
this.
you repeat again?
Okay, I will repeat that. See, here we have written some of the modal code or non-modal code. What is a modal code? That means it stays in effect until cancelled by another code in the same group. Okay, so basically, when I am not writing this G01 again and again, so this is basically a modal code. Okay, so if I won't write any other code like G02, it will means in further lines it will keep the same meaning. Okay, so these are some of the modal codes. Okay. Yes.
Sir,
Yes.
there is no G91 command for previous table. G91.
Maybe it is intense, means by mistake it is not there, but incremental system means it is G91 and absolute system means it is G90. Okay.
Okay, sir.
And okay, someone asked what is there some problem here. See, uh, if we are writing G90, it is for absolute system, and suppose my tool is here and I want to move to this point. So the location will be G01 X10. There is no Y coordinate, so we may skip this one. Okay, and we have used a semicolon, so it will reach here. Then from this point to this point, I have to write. Sorry. Here actually there will be no Y. It will be only X and Z. Suppose it will write 10 7 means we can write Z7. Okay, so it will take this path. Suppose by mistake we skip this semicolon, which represents that it is a end of block. So if we skip this means this is not the end of block. It will consider these two lines as a single line. So if the mistake is like this, instead of the tool taking this path, it will take this diagonal path. Okay, so accordingly our part will be a defective part. Okay. Now let's say we are coming for the job of turning center. So this will be the part that you have to manufacture. So all the dimensions are in mm, and these dimensions means it will be given. Okay. Now our first job, you know that in this direction it is your x is positive. Okay, and this direction z is positive, and x means this is the diametrical value. It is, so my tool, suppose my tool is here, this is the x14. Okay, if it is here means it is x16, means it is not the radius, it is the diametrical value there. Now uh, when now see, whenever my I just switch on the machine, I will find my tool in any arbitrary position. Okay. Okay, any arbitrary position. So at this position, this means the computer has no idea where is the tool. Okay, so we have to perform a operation that is called homing operation. So what is homing operation? So by homing operation, my tool will move to some extreme Z and extreme X position. Okay, so there will be some sensors, means when I will write the homing operation means it will move to the extreme Z and the sensor will monitor its location. When it reaches the extreme value, it will make sure that okay, it reached the extreme Z value, it will stop in Z. Similarly, when it moves the in X
Sir,
direction,
what
okay.
is the coordinate? Sorry, what is the programming language for homing operation? What the code we should write?
We will just get the concept while understanding the entire program. We can discuss on that. Okay. So
Yes.
we have so position 2 means this is the extreme Z and X. So at this point, it has no idea where is the tool. Once we do the homing operation, it will go to a location. This that means the extreme Z and X, and it will consider that this is the machine coordinate system or 00. Now my tool reached here and this is my 00. But let's see, my tool is here and my job is here, and this is 00 or the for the machine coordinate system. Now can I write the program with this by taking it this point as origin? This will be not convenient for programming. Okay, so what we need to do, we have to let's say this previous to machining, this job will be like this only. Okay, this part are uh, this part is not removed, so this will be like this. So what I need to do, I have to move this tool. Once I define the machine coordinate system, I have to move this tool and I can touch upon any point on this line, and I know what is the diameter of this. So I can set in the machine, like after touching in machine, I can set that this is 26 comma star. Means I am sure about this location that it is the diameter x is 26, but I do not know what is the z value. So I can define by 26 star. Now again, I will touch the tool on this line, at this line we can define that I know the x value, I do not know the x value, but the z value is on this line is 0. So if we define these 2 points, it will automatically consider that this is my 0 0. Okay, so this 0 0 is the work coordinate system which is convenient for programming. Okay, is it
So
clear?
what is the why we are writing star here?
Star means we do not know this value. See, on this line, this x value is fixed, but the z value keep on varying point to point. Okay, so we do not know this value. This 26, how we come to know? Because this is the diameter. Okay, that's why we are writing here 26, and here we have to define 0 0. So means this line represents that z is equal to 0. So on this line, x value will be it may be different, but z value is 0. So if we supply these 2 points, the computer automatically takes this as the 0 0, which is the work coordinate system, and this 0 0 is convenient for programming. Okay, and
Sir,
see, yes.
sir, why did we take x1 as 26? Because at position 3 we defined the origin, no sir, 0 comma 0. Then it should be 13 comma star, no sir.
No, no, 26 means as I written that x is the diametrical value. So what is the diametrical value? This value is 26. The diameter is 26. That means on any point in this line, x is equal to 26. Is it clear?
Yes,
This
sir.
is not the radial value. This is the diametrical value. Okay, and as
Sir,
this is my
but
zero.
hello, sir.
Yes.
Sir, but according to origin, this will be 13 millimeters, sir.
Yes, sir. According to origin.
Sir, it is 13, sir. It's not 26.
So because we
Yes, sir.
measure the distance with respect to origin, na, sir.
But in programming, we always consider this as the diametrical view. Suppose this is 13, we are telling the radius. But at this point, we are not talking about what is the radius. At this point, we are talking about what is the diameter. What is the diameter of the job at this point? It is 20. It is or at this point, it is not 7. It is 14. What is the diameter of the job at this point? This is 14. That's why I have written x is the diametrical value.
Sir, then what is the significance of origin here?
We have to define the entire program as per as taking this 0 0, that is the work coordinate system. See, this is the axisymmetric job. This is the axisymmetric job. Okay, so we have to define it by diametrical value. I
Sir,
know
so
this.
now, sir,
Yes.
so now if the tool is at origin and we write x26, then it will move to the upper that edge or the
Yes.
upper surface of that.
Yes. Yes.
Or we have to write x13.
Sorry.
Yes,
We
sir.
have
Yes,
to
sir.
write
I have the
x20
same doubt.
or x13 to move the tool to that upper thing, the point 1.
Yes. Yes.
Yes, sir.
It will
This
move.
point one we should write 13.
Okay.
If we write 26, it will go ahead.
Okay, just wait. When we will discuss the entire program, it will be more clear. Okay, now see, if this is my 0 0, so z positive means there is no machining, z negative means there will be some machining. Okay. Now,
Excuse me, sir.
yes,
So only in the x direction we consider diametrical value,
yes, yes,
and for the z direction we measure the distance according to origin.
yes, yes.
Okay, sir.
Now see, this is the same job, uh, and we have to do the turning operation. Okay. Now see, for turning, what we need to do, we have to rotate the job, and we must specify a depth of cut value. And once this depth of cut is given, suppose we reached at this point. Now, to continue machining action, my tool must move in this direction up to this point. Okay. Now it will be a gradual motion. Okay, or the feed has to be also provided. Now what is required? When reaching this point, we must specify the coordinate of this point. Okay, now after reaching here, again I have to define the depth of cut. Again I have to specify the coordinate of this point, and like this. But let's see, in that case, the depth, depending upon the depth of cut value, I must remember or calculate a number of points. Okay, or suppose that this is a slant surface. In that case, I must calculate all the points on this line, and I must give it to the machine or write in the program, which will be a difficult task. Okay, so to avoid this, what we do, there is a, we have to write it in some canned cycle for turning operation. So there will be a basically some format for that. So uh, if in that, so how can we write the program in that format? So in that format, I must write G71. If you remember, it denotes that this is the turning operation. Okay, and if I write P1000 and Q1100, that means there must be a some block or the sequence. Okay, there must be some N1000 and N1100, and in between,
Sir,
with just wait, let me complete this. And in between, I must write all the endpoints, coordinate of all the endpoints. Okay, like 1 2, because from the part program or the part drawing, I am familiar with these coordinates. Okay, if I can specify only these coordinates, okay, then, and how this motion from point 1 to point 2, here it is a linear motion. If I can specify that, and I will define and I can define some depth of cut, then automatically it can consider the intermediate points. Okay. See, so we must specify these values within. So this is basically the format for that. So in that, what this P stands for, this is the starting line number, and Q is the ending line number. Okay. And what is U and W? U basically, whenever this is the can cycle format. Okay, means that this line represents the can cycle for turning. So whenever we write something like U and W, in basically it represents the depth of cut. If we have to define the depth of cut in either X, Y, Z axis, we have to define it by writing U, V, W respectively. But in case we are writing the same U, V, W, here there is no Y axis, so it will be only U and W. But if we write the same U and W in this can cycle, it represents a different meaning. This means this is the finishing allowance in uh, finishing allowance in X direction, or this is the finishing allowance in Z direction. Okay. So what is finishing allowance? See, um, machining means this is our final dimension. Okay, and this can be achieved, means suppose there is a provision that I can remove the majority of the part, or the by rough machining, where the part dimension will be similar to this, but still I will leave some extra material on this. Okay, so what is the purpose? The extra material means this suppose here it's a you point to, suppose the 0.2 mm extra material I will leave after this operation, which will be removed by another operation called finishing operation. So what is the difference between the roughing and finishing operation? It is that in roughing operation I am more focused on removing the extra material without thinking of the surface finish. But once the dimension is approached to that the final dimensions, okay, I may go for some operation like finishing operation where I may change some of the parameters and I can machine such a way that the final surface finish will be a better, or it can be improved. Okay, so remember here the machining is done in two ways. Means first is roughing operation, where after roughing operation means suppose this is my sequence. After this completion of this line, it is not like that we have achieved this dimension. Still there will be some more material on this. Means in x direction, if this is 14, after roughing operation, it will be not 14. It will be 14 plus 0.2, 2 times your 0.2 means 14.4. Okay. Now that means there is some extra material still left. So that can be removed in finishing operation. Okay. Now coming
Sir,
to, okay.
sir, I didn't understand canned cycle for turning that thing.
Okay. Okay, let me
Sir, I
tell you.
didn't understand the meaning of U, V, and W. The allowances, what does that mean?
Can you
Okay, see.
explain
So the
P
value
and
of U
U
0.2,
again?
W
Okay, see.
0.2.
So finishing and chamfering is same.
No, finishing and chamfering are not same. See, for turning operation, what information we must give it to the computer? That means we must specify a depth of cut. Okay. So how can we define the depth of cut? So if depth of cut can be given in any of these x or z direction, it can be given means just let me see tell here. See, whenever we are writing in terms of x and z, this is the coordinate of the next point. But how the computer will understand that this is not the coordinate, this is just we are giving a depth of cut. Okay, see, from this point to this point it is moving, but how the computer will understand this is just a depth of cut. We have to specify, because depth of cut it is not we are giving it for single time. It will keep on means it will means here we are giving depth of cut means it will again after this line again we have to give a depth of cut. We cannot write the depth of cut for each time. Okay, so depth of cut along xyz axis we can write in terms of UVW. Okay, this is the first thing. Okay, now there is a confusion like again we are writing in this here UVW, it may come but it has a different meaning because we are writing in
What is
x and z.
PQ, sir?
V again PQ means this is
Sir,
just a see uh, I think you are familiar with that C code, all that thing. So in that, suppose there is a loop. Okay, means if the condition satisfies, means it will enter this sequence. Okay,
Loop,
P1000 means
yes.
this is a loop kind of thing. If we encounter this, that means at this point computer will search for N1000. Wherever it will find N1000, the control will shift to that. Okay, now in between this N1000 and N1100, we must write all the coordinates of the points.
Excuse me, sir.
Okay.
Sir, what is the meaning of N1000 and N1100?
Yes, sir.
This is
I have same doubt, sir.
this is just the starting line and ending line. If this is a loop, it must understand what is my starting line and what is my ending line. Okay. See, the computer will do certain
Sir,
operations.
for which purpose this is a starting line and ending line?
This is for the turning operation.
Okay, okay, sir.
Okay.
So the starting
So
Yes,
line
sir.
is
For
starting line.
for different operation, different value of n is given.
Yes.
Means
If there is a
if so turning and grouping
yes.
or other kind of operation, different value of n we suggest.
Yes.
Or
Yes.
what?
Okay. Now,
Yes, sir.
let's say, okay, we have already discussed it. Okay, let's say this is our the part program that you have to produce, and this is the entire program for that. Our job is to understand the program so that we can write the same program for another part also. Okay, and this program is fed to the computer, and computer will means it will read the command line by line, and it will the tool motions will be accordingly. Okay, so first see, this is the turning operations we have to do. So first written G50 S2800. What does it represent? G50 means, if you will remember, if you can go through the slides, G50 is the maximum speed setting. Okay, that means my RPM should not exceed 2800. Okay, and then G0 T0606. What does it mean? T0606 means we are selecting a sixth number of tool. Okay, as you know that there will be a turret, which is a box kind of thing. There will be 8 number of tools are there. So out of that we are selecting the sixth number of tool. Okay, and the second 06 is an offset number where all the informations regarding the tool is stored. Okay, and M42, that means, what is M42? M42 means we are taking the what is that? The spindle speed high, means we are operating. M42 means spindle speed high, means the RPM will be greater than 1000. Okay. Now
So for
G96.
programming, we need both the codes, G and M code.
Yes, yes. Okay.
So it
And
cannot be done only by single code.
no, no. See, G codes and M codes are different. If you will go to that slide, the definitions are different and their operations are also different. Okay, M codes means sometimes we write it for spindle speed, means clockwise motion, counterclockwise motion, chalk clamp, chalk on clamp, or that coolant on off, program end, or all those things. But G code means it is basically